Okay, so now we're going to learn one last division technique with polynomials, and this is called polynomial synthetic division, and I have a feeling you're going to like this better than long division. So first, before we do that, I want you to divide these two polynomials using long division. Pause the video, do that, unpause when you're ready to discuss. Alright, so here we should end up with 3x squared minus 5x plus 7 plus negative 12 over x plus 1. Just to go through it again, how did we get that? So first we have our setup here in red. And then I take the 3x to the third and I divide by x. So 3x to the third divided by x is 3x squared. So I write that up top in green. Now I multiply in blue. So 3x squared times x is 3x to the third, and 3x squared times 1 is 3x squared. Now I subtract in purple. 3x to the third minus 3x to the third is 0. Negative 2x squared minus 3x squared is negative 5x squared. 2x minus 0 is 2x. Negative 5 minus 0 is negative 5. Great. Now let's repeat. So I take the negative 5x squared here in black, and I divide it by x. Negative 5x squared divided by x is negative 5x. Write that up top here in black. Multiply in blue. Negative 5x times x is negative 5x squared. Negative 5x times 1 is negative 5x. Subtract in purple. Negative 5x squared minus negative 5x squared is 0. 2x minus negative 5x is actually 2x plus 5x, so that is 7x. Negative 5 minus 0 is negative 5. Let's repeat again. Take the 7x, divide by the x. 7x divided by x is 7. Write that up top here in green. Multiply in blue, not boo. 7 times x is 7x. 7 times 1 is 7. Subtract in purple. 7x minus 7x is 0. Negative 5 minus 7 is negative 12. Here is my quotient, which is the result of the division, and then plus the remainder divided by the divisor. Okay, great. Not too bad. Or maybe it was. I don't know. Depends on how you feel. But the question is there an easier way? And the answer is sort of. Yes. Sometimes. And that easier way is what we call synthetic division. Now, synthetic division only works if dividing by something of the form x minus k. Now keep in mind, when we write this x minus k, it doesn't mean that it literally has to be minus a number. It just means that it has to be x plus a number or x minus a number. So for instance, this here is what we call x minus k, because I can think of that as x minus negative 1, so it's x plus 1, right? So examples would be like x minus 3, x plus 7. These are good examples, okay? These are things that I can do synthetic division with. But if I have something like 2x minus 3, no, because of the 2. And if I have something like x squared plus 7, no, because of the x squared. So, how do I do synthetic division? Great question. Glad you asked. Let's go through it. So if I have something that I'm dividing by that is of the form x minus a number or x plus a number, then I'm going to take that thing, so in this case the x plus 1, I'm going to set it equal to 0, and I'm going to solve for x, and I'm going to take that number, I'm going to write it, I'm going to put it in like a little half of a corner, or I guess a corner. Now, I'm going to take the coefficients from what I'm dividing, and I'm going to write those, giving myself a little bit of space. So I'm going to write 3, negative 2, 2, and negative 5. Now I'm going to, again, give myself a little bit of space, and I'm just going to draw a line. Now for this process, remember with long division, our process was divide, multiply, subtract, repeat. With synthetic division, our process is actually add, multiply, repeat. So notice that there's not even division in it. Huh, how does that work? Crazy. So first I'm going to add. What is 3 plus 0? That's 3. Great. Now I'm going to multiply. What is negative 1 times 3? And if you're wondering where's the negative 1 coming from, the negative 1 is right here. And the 3 is right here. So negative 1 times 3 is negative 3. So I'm going to write that here. Now I'm going to add again. What is negative 2 plus negative 3? That's negative 5. Now I'm going to multiply again. What is negative 1 times negative 5? That's positive 5. Now I'm going to add again. What is 2 plus 5? That is 7. Now I'm going to multiply again. What is negative 1 times 7? That is negative 7. And now I'm going to add again. What is negative 5 plus negative 7? Negative 12. Okay, almost done. Now, I have to recognize the original thing that I was dividing was x to the third. So my result of synthetic division is always going to be 1 degree less than that. And that is going to relate to the first term here. So that was a 3. So this 3 is the coefficient of my new first term, which is 1 degree less than the original first term. So my quotient is 3x squared minus 5x plus 7. This value here is my remainder. So I'm going to have plus negative 12 over x plus 1. Look at that, right? Look at that. Same thing. Same answer. A little bit different work. Okay? So again, the couple of key things. The setup, it is add vertically and then multiply diagonally. So I always multiply by this number. And then the results, the last number here is always your remainder. And the first number here is the coefficient of a term that is 1 degree less than what we started with here. All right, so let's try to do A and B. First, let's do the setup. So for the setup, I took what I'm dividing by, x minus 1, set it equal to 0. I got x equals 1. I put that in my little corner. And then I write out my coefficients. Now notice I have this 0 here, and that's for the same reason with the long division. Since I started with x to the third, I have to put in a placeholder for x squared. So I can think of this polynomial as x to the third plus 0x squared minus 3x plus 2. So that's where that 0 is coming from. Okay, so now let's go ahead and do the synthetic division. So remember, we start with addition. Then I'm going to do 1 times 1, which is 1. So that's going to go here. 0 plus 1 is 1. 1 times 1 is 1. That's going to go here. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. That's going to go here. 2 times negative 2 is negative 4. So now I can write my answer. Since this was a third degree polynomial, I know that my result is a second degree polynomial. So this is going to be x squared plus x minus 2 plus negative 4 over x minus 1. Any questions on that? Okay, good. Moving on. All right, I want you to, for B, try the setup. Pause the video, set it up, unpause when you're ready to check the setup. All right, so my setup, I should end up with negative 2 in the corner because I'm dividing by x plus 2. And then my coefficients are 1, 3, 0, and negative 4 because I can think of this as x to the third plus 3x squared plus 0x minus 4. All right, I want you to try and go ahead and do the synthetic division. Pause the video, unpause when you're ready to discuss. All right, so here we should end up with x squared plus x minus 2. Notice that we have no remainder here. That's nice. How did I get that? So 1 plus 0 is 1. Negative 2 times 1 is negative 2. So I wrote the negative 2 here. 3 plus negative 2 is 1. So negative 2 times 1 is negative 2. I wrote that negative 2 here. 0 plus negative 2 is negative 2. So negative 2 times negative 2 is 4. I wrote that 4 here. Negative 4 plus 4 is 0. So then my coefficients of my result are 1, 1, and negative 2, and the result starts 1 degree less. So since this was x to the third, this is 1x squared plus 1x minus 2. Nice work. All right, I want you to try and do 3 and 4. I know this is a lot of work, but this just takes practice. Again, just like long division, it's not a difficult process, but we just have to be careful with our positives and negatives and really make sure we understand the process. So go ahead, pause the video and do 3 and 4. If you get stuck at any point, just unpause and see what happens. Okay, for the first one here, we should get x squared minus x minus 9 plus negative 12 over x minus 2. How do I get that? Well, I set the divisor x minus 2 equal to 0, and I get x equals 2. Put that in my corner. My coefficients are 1, negative 3, negative 7, and 6. 1 plus 0 is 1. 2 times 1 is 2. Negative 3 plus 2 is negative 1. 2 times negative 1 is negative 2. Negative 7 plus negative 2 is negative 9. 2 times negative 9 is negative 18. 6 plus negative 18 is negative 12. The original polynomial was x cubed, so my result is x squared. So this is 1x squared minus 1x minus 9 plus the remainder over the divisor. All right, if you didn't get that one or the second one, go ahead and pause the video and try the second one again, number 4. Unpause when you're ready to check. All right, so number 4 here, we should end up with 2x squared minus 6x plus 17 plus negative 58 over x plus 3. How do we get that? Great question. So x plus 3 equals 0. I get x equals negative 3. Put that in my corner. My coefficients 2, 0 because there's no x squared term, minus 1 because it's minus x, and then minus 7. 2 plus 0 is 2. Negative 3 times 2 is negative 6. 0 plus negative 6 is negative 6. Negative 3 times negative 6 is 18. Negative 1 plus 18 is 17. Negative 3 times 17 is negative 51. Negative 7 plus negative 51 is negative 58. My original polynomial here was x to the third, so my result or quotient is x squared. So I have 2x squared minus 6x plus 17 plus negative 58 over x plus 3. Boom. All right, so hopefully we understand synthetic division only works if we're divided by something of the form x minus k. But if we have that form, it does make the division of polynomials easier or quicker or more efficient with less room for error. But it is still very process-oriented, so we really need to make sure we understand the process, pay attention to positives and negatives, same as with the long division.